Here is a tutorial on how to graph data in Excel and generally the graphs and how I expect your spreadsheet to look that you submit to me. When you graph data in Excel, it's typically easiest to put the data you want on the x-axis in column A or in the column on the left, and the data you want on the y-axis in column B or the column on the right. So let's look at how we would go about generating a graph like this. Okay, I'm going to open a new sheet and paste this here. So I've got my volume data and I've got my mass data. So what you want to do is you want to highlight the data like this, select Insert, and here under the Charts tab, we're going to want the scatter plots. Now this generates a chart, and we see we've already got a chart title. So remember that chart titles should be written as Y versus X. So I should write this as mass versus volume. Again, you can get more descriptive with these titles if you wanted to call this plotting mass versus volume to determine density. You could do that, but you always want to write this as Y versus X. Okay, the next thing we want to do is we want to add axes titles because we don't have them right now. So you're going to go right here to this plus button, Chart Elements. Press the plus button and select Axis Titles. So this puts an axis title on both the X and the Y axis. We'll select the axis title and we'll label it. So the X axis is volume, and then we need to put our units in parentheses, milliliters. We'll do the same thing here on the Y axis. The label is mass and the units is grams. Okay, now the next thing we want to do here is we want to add a trend line. So to add a trend line, you click that plus button, Chart Elements, and you click Trend Line right here. And that populates the data with a trend line. Now we want to add the equation to our graph or on our trend line, and we want the R squared value. So to do that, click this little black triangle right here. You click More Options. You want to be under Trend Line Options, and you want to be under this tab with the 3 bars. You scroll down, you select Display Equation on Chart and Display R squared value on Chart. And you can click this and move it like so. Okay, if you want to edit the trend line in any way, you're going to right click, or excuse me, the trend line label. You right click on it, click Format Trend Line Label, and you can change it to a number, and you can add or remove decimal places like this. Okay, the last thing we want to do here is we want to shrink some of this white space down. So again, this is more of a personal preference of mine, but I think graphs look much neater, much cleaner, and more professional when white space is eliminated. Remember that your graphs do not have to necessarily start at 0. Like look at the mass axis. It starts at 104 and it goes to 116. So to edit that, you're going to click on the axis, right click, and select Format Axis. Here you can see the bounds, minimum of 0 and a maximum of 9. So we're going to change that minimum to 2 and change that maximum to 8. All right, now if you wanted to change the decimal places on your axis, staying under Axis Options, you scroll down here to Number. Now see this is set to a category of number, so we can edit the decimal places. So I could add decimal places, or I could remove decimal places, but I'm going to stick with 2 because the volume measurements you took in this experiment should have 2 decimal places. Now I want to do the same thing for the y-axis, so I'll right click, Format Axis, and I'm going to make my minimum 104 and my maximum 116. And then again, I could add more decimal places if I wanted to, but I'll keep it at 2. Okay, and that is all you need to do to generate the graph here. So this is how you generate the graph for mass versus volume, and you're going to have 5 graphs like this. 1 for solution A, 1 for solution B, 1 for solution C, 1 for solution D, and 1 for the unknowns. These 5 graphs, graphing mass versus volume, this is how we graphically determine the density of that solution. And remember, the density of the solution here will be represented by the slope, because the slope is y over x, which is mass over volume, and that is density. So here, based upon this data, we would determine that the density of the unknown is approximately 2.00 grams per milliliter. The final graph that you need to have on your sheet is that graph that compares density versus fructose content. So this graph, you absolutely have to make this graph to be able to determine the fructose content of the unknown for your post-lab data. So to generate this graph, you're going to want the density values from each of the 4 known solutions. And remember to use the density values that you determined through the direct method. So for solution A, B, C, and D, we've got their fructose content. So that's grams of fructose, just fructose, divided by milliliters of solution. And then we've got the densities that you determined using the direct method. So what you want to do here is you want to graph on the x-axis the fructose content and on the y-axis the density values. And you're going to follow the steps that I outlined. It'll work exactly the same as what I just showed you here. To generate your graph, add your trend line label showing the equation and the r-squared value. And then you're going to use this equation right here to determine the fructose content of the unknown. So that is the simple walkthrough of how you're going to generate graphs, how you can generate scatter plots, add axes labels, change the title, change these labels, add a trend line, add the trend line labels, and edit those trend line labels. So this is everything that you need to know for this experiment. If I've forgotten anything, or if you're feeling confused still about anything that you need to do for this post lab, please feel free to reach out and email me or come to office hours.